6.1, you can ignore where it says Unit 4 here. I forgot to update that part. We are in Unit 6. Lesson 1, we are going to be working with adding polynomials. So today we are going to practice combining like terms so that we can add polynomials, and you'll be able to do it when you can simplify an expression that involves adding polynomials. So remember that combining like terms requires us to simplify an expression by calculating all of the like terms using addition and subtraction. So when we're working with polynomial operations, we'll continue to combine like terms to simplify the addition of polynomials. So if we're talking about the general form of a polynomial, we can have any number of terms. Remember, a term is like an individual unit. So negative 2x to the fourth power is a term. That is a term. 3y to the ninth power, actually that we wouldn't like that. 3y to the third power is a term. That is positive 3y. This is negative 2x. We could have like negative 15x to the second, y to the fifth. And that whole thing itself is a term. So when we're looking for like terms, what we're looking for are similar, actually identical exponents, variables and exponents. So for example, 2x to the fourth plus 3x squared plus 7x to the fourth minus 14x squared. My like terms are the ones that have the same variable and the same value exponent. So x to the fourth, I have 2x to the fourths and 7x to the fourth. So those combine to make 9x to the fourths. I also have 3x squareds and negative 14x squareds, and those combine to make negative 11x squareds. So combining like terms means that we're taking the terms that have the same variable and exponent value and counting them up. So the difference with adding polynomials is just that these are grouped together. So I have a group here plus a group here. And when we're adding, we don't even really need to, when we're adding, there's not really going to be any change. We're able to rewrite each group without parentheses. When we move to subtracting, you're going to see some differences there. That'll be in the upcoming classes. So today we're just going to work on adding like terms. And so here's what I'm going to do. This plus sign means that I'm taking my first group values and I'm adding my second group values to it. So I'm going to line up and I'll do some, I'm going to put my x squared in this column. I have an x squared. I also have a negative 4x, so x to the first power. And then I have just a regular 5. That's a constant term, so that's going to go in this column. So I'm going to do x squareds in this column. I'm going to do x to the first in this column, and I'm going to do regular numbers in this column. And I have a regular number here. I have an x to the second power there, or a regular x, 2x, and then x to the second power. So if I were to put these where they belong, I have 1x squared, negative 4x, and positive 5. Should probably put signs. And then I also have a positive 6x squared. I have a positive 2x, and I have a negative 1. So all I did was I organized all of these numbers where they belong. So I put them in a group, I put my purples in a group, and I put my greens in a group. Now all I have to do is combine each group. So 1 plus 6 is 7. So there are a total of 7x squareds. A negative 4 plus 2, signs are different, so we'll subtract and keep the sign of the larger number. So 4 minus 2 is 2. Our larger number was negative, so there are negative 2 x's. And then 5 minus 1 is 4. And now we have simplified that expression. So I'm going to do it without all the color coordinating on B. I have a 2x squared plus 8x minus 3. So I just rewrote these three things. And now I'm going to take my x squared, I'm going to write it plus 1x squared, and my 3 goes here, plus 3. And now I can combine these. So 2 plus 1 is 3. 8x didn't have anybody to add with, so it just stays positive 8x. And a negative 3 plus 3 is 0. They cancel each other out. I could write plus 0, but it's not really necessary, right? Because I don't have to point out there's nothing there. So this is our final answer there, combining those ones. Let's keep practicing these. So I'm going to take, now if you notice I have crazy, there's kind of some crazy order here. So I'm going to look across and I'm going to say, what's my biggest exponent that I have? I have a 4, n to the 4th. So I'll show you a way to organize this. We're going to have an n to the 4th column. And then we're going to go all the way down. N to the 3rd, n to the 2nd, n, and our numbers, our constant terms. So let's just put everything in the column that it belongs. So I'm going to look at this one. 4n to the 3rd means that that one goes here. Check. Did it. Negative 3n to the 4th. That negative sign is attached. Negative 3n to the 4th, well, that's going to go in the n4 column. Negative 3n to the 4th. Check. Did it. Positive 9 is just a regular number, so I'm going to put positive 9 in my regular number. 2n to the 2nd goes in my n to the 2nd category. Negative 9 is just a regular number, so I'm going to put a negative 9 here. And negative n to the 3rd is going to go here. Negative n to the 3rd. And if we don't have a number next to it, we know it's just a 1. So now I put every term in its category. I didn't have any regular n's here. I didn't have anything to put in that category, but I listed it because I wanted to go in order. 4, 3, 2, 1 numbers. So now all I'm going to do is I'm going to look at each column. So here, negative 3n to the 4th isn't being changed by anything. So negative 3n to the 4th. And then I have 4n to the 3rd minus 1. 4 minus 1 is 3. So I'm going to be working with a positive 3n to the 3rd. Oops. 2n to the 2nd had nobody to combine with, so it stays positive. I should have written positive. Positive 2n to the 2nd. N to the first power, there was nothing there, so I'm not going to write like plus 0n to the first power. I'm just going to leave it out because there was nobody there. And then positive 9 minus 9 is 0. That makes 0. So there's nothing really to write down. So when I simplify this one, I'm left with negative 3n to the 4th plus 3n to the third plus 2n to the second. All right, so I'm going to do that same strategy here. I'm going to look at what's my largest exponent value. And my largest exponent value is a 3. So I'm going to have x to the third, x to the second, x to the first, and my regular numbers. So everybody should have a category to go to. So I'm going to take x to the third. And that goes in this category here. I'm going to take positive x. That's x to the first, so there's x to the first. And negative x to the second is negative x to the second. So all those guys went where they belonged. And then 2x, that's x to the first, so 2x to the first. Negative 12 is a regular number. And positive 5x to the second. So that's positive 5x to the second. Now I've put everything where it belongs. And I'm going to go and just combine the ones that I have. So x to the third, a negative 1 and positive 5 is a positive 4. A positive 1 and a positive 2 mean there are 3 x's, remember, because this is 1x. And then a negative 12 doesn't combine with anybody. So here is my answer written in descending order, which means I have largest exponent down to my smallest. Okay, last two. I'm going to look through and I'm going to say, what's my largest exponent here? I see a 3, so I'm going to go x to the third, second, first, and regular numbers. So I have x to the third, x to the second, x to the first, and my regular numbers. Okay, and then I'm just going to go one piece at a time. So I'm looking here. A regular x, I'll do these in blue, is going to go in my x to the first. A negative x squared. And a negative x to the third. So I did each one of those. So I did x, I did negative x squared, negative x to the third. This negatives are attached, right? Positive x to the third means I'm going to do a positive x to the third here. Negative x to the second means I'm doing a negative x to the second here. So I wrote those ones down. And negative x goes there. I didn't have any regular numbers by themselves. So I don't have anything in that category. And then I'm just going to combine them. So I'll do this in purple. A negative x to the third and a positive x to the third cancel each other out. There are none of them. A negative x to the second and a negative x to the second, the signs are the same. So we add 1 plus 1 is 2 and keep the signs. So negative 2x to the seconds. And then x minus x, 1 minus 1, is 0. So these also zeroed out. So my answer is just negative 2x to the second. Everything else canceled out. All right, and our final example. So again, I'm going to look for my largest exponent, which in this case is 4. So I'm going to write in descending order. I'm going to go 4, 3, 2, 1, right? And then our constant terms, or whatever our numbers are. So I'm going to take 8x, and 8x is going to go in this category here. Done. 7x to the second is an x to the second. Done. 2 is a regular old number, so that's going to go here. 4 is a regular number, so that's going to come in this category as well. Negative x to the second needs to go over here. and positive x to the fourth needs to come over here. And if it doesn't have a number next to it, remember it's a 1. All right. And now I'm ready to just combine each category. So here I have 1x to the fourth, doesn't change. My next one, 7 minus 1 is 6. 8x doesn't change. And 2 plus 4 is 6. Okay, so this is our polynomial that we're working with. Okay, so everything has its own little category. Now, if you've done these before, or you're seeing that, hey, I can do this mentally, I can look for the ones that are similar and then just add or subtract in my head, you're welcome to do that. But this is a great way of organizing our work and making sure that we put everything together. As long as we know how to add and subtract numbers, we can get through doing these pretty easily. Remember that we never really changed our variable or exponent. All we did was we counted up the numbers in front. So that's all we're really doing on these, okay?